This is the first parameter which is involved, like this one, right? This is the first parameter, and second is this. So this particular parameter is your width, and this particular parameter is your length. This is your depth. Now this part is your depth. Can you see any involvement of depth in the surface? No. Depth is not at all involved in surface, right? What is involved? Length is involved and width is involved. So surface area is always written as L into B. So this is your surface area. Now when I write cross-sectional area, now I'll show you the cross-sectional area with some other color, right? I'll show you the cross-sectional area with some other color if I'll be able to show. Alright, I'll make it on my own. Yes. See, this which I mentioned with the pink color, you must be able to see this part. I am mentioning it with pink color. Right? Now when you see this pink color, which two parameters are involved in the calculation of this area? One is this parameter and another is this parameter. So this is what? This is again the same parameter, this which we already discussed, this width. So this is nothing but your width. So width is involved. Yes, in cross-sectional area also width is involved. But when I tell you, when I see this particular diagram, there are two particular dimensions involved in the calculation of cross-sectional area, and that is, one is your width, another is your height or depth. If you see from the top, it is depth. If you see from the bottom, it is height. So right, so this is nothing but your height, this is nothing but your width. So cross-sectional area is going to be B into H. So B is common in both the places, but in the surface area we will be considering the length, whereas in the cross-section area we will be considering the depth or the height. I hope the concept is absolutely clear to you guys, right? I hope the concept is absolutely clear to you guys, right? Alright. Now let us move back to our original table. I hope you guys have seen that. Now we were at surface area. What is surface area? Surface area can be written as we discussed here, it is L into B. But this L, length, is also your what dimension? L, and this is also L. So surface area or cross-sectional area or any area will have the same dimensional analysis. See, unit wise, concept wise, surface area and cross-sectional area both are different. We have seen cross-sectional area and surface area both are different. But if I make the dimension analysis, this is also 1L, this is also 1L. So what it will be? It will be L square, right? And again, this is also one length, this is also one length. Dimension analysis again says this is going to be L2. I hope you got my point, right? So this is L square, this is L square. As per the dimensional analysis, both of them are same, but conceptually both are very different. Conceptually both are very different, right? So this is how units are different, dimensional analysis is different, and concept is different, right? So surface area, cross-section area, or any area will have the dimensions as or dimensional analysis as L2. I hope you are crystal clear with the concept, right guys? Now let me show you next parameter. The next fifth parameter is going to be force. Now this force F is given by mass into acceleration. Now this force F is given by mass into acceleration. Now when I say mass, acceleration we have already done. This is Lt minus 2 and it is having one mass, right? So F can be given by m into Lt minus 2. Lt minus 2 is coming from your acceleration. So dimension analysis will be m1 L1 t minus 2. If I write something as 1 and I do not write anything, it means the same. If there is nothing written, like here I am not writing L, anything on the power L, but I can write 1 also as the power. Same I am writing with ml. So either you can write m1 l1 or you can write simply ml. Alright, one and the same thing. So this is again your force. So we have made the dimension analysis of force also. Now we have already discussed about the volume, a lot about the dimensions of length. So volume is what? V is your L into L into L. So V is going to be L cube. So this is very simple. We have already discussed this with you guys, right? Now next is density. Next is density. Now when I enter into the density part, what is density? Let me tell you first of all. Density is nothing, it is denoted by D and is given by mass per unit volume. Density is nothing but your mass per unit volume. Now you know what is the dimensions of mass. So this dimension of mass, for mass I will be writing m1. What is the dimension of volume? L cube, but this L cube is now in the denominator. This L cube is now in the denominator. This L cube is now in the denominator. So it will become L minus 3. So this is going to be the dimension analysis of the density. This is going to be the dimension analysis of the density. So see this very clearly, you guys, see this very carefully. Now we will be moving to the next page and we will be making one very famous dimension analysis which is going to help you in every step, in every topic which will be coming further, right? Let me have a sip of water, then we will be discussing the final dimensional analysis, right? Alright guys. Alright, let us move. You understood this concept. Now we are moving to another concept, and that is going to be dimensional analysis of energy. Dimensional analysis of energy. Now before I make this dimensional analysis, I will explain a few concepts to you guys, right? Now this energy, all of you must have heard about the famous law of conservation of energy, and energy can neither be created nor be destroyed. It can just be transferred from one place to another, one form to another form, right? Let me repeat the concept. Energy can neither be created nor be destroyed. It can just be transferred from one form to another form, right guys? So this is why when we are transferring energy from one form to another form, we have n number of energies. How? We have the kinetic energy. Let us consider the example of a dam. What happens at a dam? At a dam, we take whole sum of water to a height and we store it at a height. When the water is stored at a height, it is having some potential energy, guys. What it is having? It is having some potential energy. And then that potential energy is converted into kinetic energy. When we allow the water to fall from this height, the energy which was stored in the form of potential energy is then converted into what? Your kinetic energy. And then that kinetic energy is used to rotate your turbines, which are present at the bottom of the dam. And when the turbines rotate, your electricity is produced. So what we are doing at a dam to produce the electricity, we are just rotating the turbines with the help of energy. Which energy? We are converting the potential energy into the kinetic energy, which is rotating the turbines and is converted into rotational energy, which is further created into electricity energy. Right guys? So I explained another concept to you. Why I explained this concept? That energy has so many forms. My concept here was this energy will be having so many forms. Like I will write it in the center. Now this energy which I am writing in the center will have so many forms. One, it can be potential energy. Another, it can be your kinetic energy, which I just discussed. Another, if I say, it can be heat energy. Another, it can be your electric energy. Electricity you can write, right? Another, it can be your sound energy, it can be heat, electricity, sound, kinetic, potential, or rotational energy when it is rotating the turbines. I'm considering the one example only, right? And similarly we have n number of energy forms. Energy just keeps on rotating on this planet. Energy just keeps on rotating on this planet in one form to another form. Energy just keeps on rotating on this planet in one form or the another form. It is neither created, it is neither destroyed. So now my question to you is, will we have one single dimensional analysis for all the energies, or we need to make separate dimensional analysis for all the energies? The concept is very simple. When we were discussing about the area, though the areas were different, though the type of area was different, one was surface area, another was cross-sectional area, but the dimensional analysis was same. Similarly, though the number of energies or number of forms of energy are different, n number of forms, but dimensional analysis is going to be same for everyone. Let us consider the example of kinetic energy. When I say kinetic energy, what does it mean? Kinetic energy means, we know the basic formula of kinetic energy, it is half mv square. What we have? We have half mv square. Now let us go back to the note page first. This is your note page. This is your note page. Now third note which I am adding into it is numbers or constants has no dimensions. Now what is the meaning of it? The meaning of it is, suppose I write 2ab. Now a and b can have dimensions because they are some forms of basic physical quantity, but this 2 is what? A constant. This will have no dimensional analysis. Why I mentioned this? So please pick up with me. Numbers and constant has no dimensions. So why I mentioned this? When I say kinetic energy, this half is not going to have any dimensional analysis. This half is not going to have any dimensional analysis, right? So how it is going to be? For m, we will be writing m. For v, what is the value of v? V is your speed or velocity. This is going to be lt minus 1. Speed is what? Your distance by time. Distance is what? L. Time is what? T minus 1, right? So this is going to the power 2. So this is going to be m. L2, m is 1, m is 1, L is 2, from the power 2 it is coming, and T is again minus 2. So this is your dimensional analysis of energy, and this is going to be same for all the forms of energy. This is going to be same for all the forms of energy. Now, whosoever asks you what is the dimension analysis of energy, you will be mentioning only one thing, that is m1 L2 T minus 2 for all these forms of energy. Now, form of energy can be any, but this is going to be same. If you cannot believe me, if you are not ready to believe me, I can show you some more examples related to it, right? How? I'll show you. Don't worry. You won't believe me? I'll show you one more example, then you will believe me. What is the value of potential energy? Potential energy is the mass stored at some height. When it is stored at some height, there will be acceleration due to gravity acting on it. So what is the formula of potential energy? It is mgh or mhg, some mass stored at some height with some acceleration due to gravity, right? So what is the value of m? M will remain m1. H is what? Your height. So what it will become? It will become L1. Acceleration is what? L1 T minus 2. So what it will become? It will become M1 L2 T minus 2. Can you find the same thing with the kinetic energy also? Can you find the same thing with the kinetic energy also? Now potential energy is what? mgh, and mgh can be written as m1, again one L1 for height, at some height it is stored, and height is what? A distance. Acceleration is what? L1 T minus 2. This is acceleration only, na? G is what? Acceleration due to gravity. This is L1 T minus 2. So these L1 will combine and will form M1 L2 T minus 2, and this is same. So this is why I am saying dimension analysis of all the energies, the value is going to be M1 L2 T minus 2. T minus 2. Now whatever the form of energy you may consider, but the dimensional analysis is going to be same. Whatever the form of energy you may consider, the dimensional analysis is going to be same. I hope you guys are crystal clear with the concept and dimensional analysis of energy as well, right guys? Just see it, and then we will proceed to the next concept. You can take a screenshot of it, you can read it thoroughly, just to have a super clarity of the concept, right guys? If you will not have the clarity, there is no point of studying it, right? Come then. Now we will proceed. Now we will proceed to the next point. The next point says applications of dimensional analysis. Now, what is the meaning of it? See, I'll tell you guys. When I say dimensional analysis, try to understand. Sir, you told us very wonderful thing. We enjoyed thoroughly whatever we studied with the dimensional analysis, right? But sir, can we use it somewhere? What will be the application of it, sir? Yes, my dear student, we have understood this wonderful concept in order to apply it in the different parts of the physics. We will be applying this concept in the different parts of the physics, right? Let me tell you how. The very first application is to check the dimensional correctness, of an equation. Now since we have become very smart and we have understood the dimensional analysis, we can check the dimensional correctness of an equation. Let us consider first equation of motion. What is it? This is written as V is equal to U plus AT, right? When I write V, see, if the equation is V is equal to U plus AT. Now, if the equation is dimensionally correct, LHS should be equal to RHS, isn't it? If the equation is dimensionally correct, the LHS should be equal to RHS. Let us see. For V, or the velocity, what we will be having? We will be having L1 T minus 1. Now this is our LHS. Let us see what this RHS says. This is L1. This is L1 T minus 1. Again, right guys? Plus. A is what? A is nothing. Acceleration is what? Your L1 T minus 2. You can check the previous notes if you are not still getting it, right? Into, what is this? This is again a time, right? When I multiply T minus 2 with T plus 1, this is plus 1. So this is going to be L1 T minus 1 plus L1 T minus 2 plus 1. So this is going to be L1 T minus 1 plus L1 T minus 1. So what we are getting is addition and subtraction will not make any change. It will be same L1 T minus 1 on the RHS and L1 T minus 1 on the LHS also. Now you guys can see it very carefully that an equation can be dimensionally checked. If the equation is correct, it has to be correct as dimensional analysis also. Now the dimensional analysis, how it can be used? It can be used to check the correctness of an equation. Now you have become very smart. You can check the equations of motion. All right guys, so first application of dimensional analysis is to check the dimensional correctness of an equation. Now I am giving you homework here, and what is the homework? You will be checking the dimensional correctness of S is equal to ut plus half at square. You will be checking the correctness, and v square minus u square is equal to 2as. You will be checking the correctness of both these equations. This is your homework, right guys? You will be checking the correctness of these two equations also, right? So you can do this afterwards. Now let me tell you, with the help of this first application, how you will be able to solve questions in your examination. Because the ultimate aim of a student is what? To crack the questions in the examination, isn't it guys? Let me tell you how you will be able to make it. Now let us move to the next page. The next page, we will be writing a question. Now what does the question says? The question says the acceleration a of a particle varies with time. The question says the acceleration a of a particle, varies with time t. The acceleration a of a particle varies with time t, right? This is the first condition. Has an equation. Now I'll be giving an equation, right? What is the equation? The equation says, this is an actual question which is asked in your previous year questions, right? This is an actual question which was asked in previous year in some examination, right? So this is a is equal to pt square plus qt plus r. This is the equation, right? Where p, q and r are constants. Where p, q and r are constants. So these are your constant values, right? When I write these are the constant, what is the first thing coming in your mind? The first thing which should come in your mind is that constants are dimensionless. They do not have any dimensions, right guys? Now find the dimensions of p, q and r. Find the dimensions of p, q and r. Find the dimensions of P, Q and R. Now see, I'll tell you, if these P, Q and R are having the values like 1, 2, 3, 4, suppose A is equal to 2t square plus 3t plus 5 was given, then 2, 3, 4, these are the numbers. They do not have any dimensions. But when they are mentioning P, Q and R, P can have any value, isn't it? P can be a notation used for momentum. So if it is momentum here, what is the dimension of it? Q can what? Q can be charge here. If it is charge, what is the dimension of it? R can be some radius, that means some length. Getting it? So though they are constants, but they are written in the form of the variable. Question says check it, if they have some dimensions, let me know. Check it, and if they have some dimensions, let me know. Okay, let us solve this question, right? Now so when I say constants do not have dimensions, it should be only numbers. When you have numbers, they will not be having any dimensions, right? I'm crossing it here. Alright guys, but when we have P, Q, R, these values, P can be momentum, Q can be charge, R can be radius. Alright guys, so P, Q and R can have the values. Got my point very clearly? Alright, now let us solve this question. In these conditions, you will be equating, see, I told you, let us see this particular analysis when we did this. Now, here it was L1 T minus 1. You can see it very clearly, this value is equal to this value plus also this value. So, this 1 is equal to, this 1 is equal to 2 and also equal to 3 separately. What I am trying to say, 1 is equal to 2 and 1 is equal to 3 also. Right guys? Similarly, LHS is equal to RHS all the values. Now let us say here, A is equal to PT square. Let me mark this as 1, this is your 2 and this is your 3. So A is equal to PT square, A is also equal to QT and A is also equal to R. Why? Because addition and subtraction does not make any changes in the dimension analysis. Addition and subtraction does not make any changes in the dimension analysis. I am repeating it, right guys? Now say this. Now this A is given as LT minus 2. Let us make dimension analysis of all these three, right guys? Now this is LT minus 2, this is P. And this is T. T square means what? This means T2, right guys? So this is LT minus 2 and this is P. If what should be the value of P? When I write LT instead of P, if I write LT minus 4 into T square, what is the answer I am getting? I am getting LT minus 2. LT minus 2 equals to LT minus 2. So what is the value of P? The value of P is coming out to be LT minus 4. So the dimensions of P will be nothing but the dimensions which will help this particular RHS to match the dimensions of LHS. Let me make another solution so that you people are more clear with it, right? Let me make another solution. A is equal to R. See this first. This is simplest, right? This is simplest. When I say acceleration, acceleration is same. Acceleration is having the values of LT minus 2. And here we are having R. So what should be the dimensions of it? It should be LT minus 2 only. So dimensions of R is what? LT minus 2. This is simplest. Now when I make this, LT minus 2 is what? RHS again, LHS again. What is RHS? RHS is Q into T1. Now in order to make T minus 2 on the right hand side, what I need to do? I need to write L1 T minus 3 so that when I multiply it with T plus 1, it becomes what? L1 T minus 2. So what are the dimensions of Q?